Alright, picture this. You're in a spaceship, sleek, futuristic, probably equipped with a coffee machine because priorities. But this isn't just any spaceship. No, this thing is traveling at the speed of light. You're moving so fast that time itself is starting to get weird. And then, out of nowhere, you feel it. That telltale tickle in your nose. The kind that lets you know a sneeze is coming, whether you like it or not. Now, normally, sneezing is just an everyday inconvenience. But what happens when you're moving at 299,792,458 meters per second? Does your sneeze even come out? Does it shoot out of your nose like a microscopic bullet? Or do the laws of physics just throw up their hands and quit? Buckle up, because today we're answering the ridiculous but surprisingly complicated question. What if you traveled at the speed of light and sneezed? Now, before we go full science mode, let's get one thing straight: humans cannot actually reach the speed of light. Sorry to ruin the dream. Physics just won't allow it. As you get closer and closer to light speed, your mass increases, requiring more and more energy to keep accelerating. And by the time you hit 99.9999% of the speed of light, it would take an infinite amount of energy to push you that final fraction. So, unless you have a physics-breaking engine lying around, the best we can do is theoretically imagine what would happen. That said, let's suspend reality for a second and assume that you, in your high-tech, definitely not science-approved spaceship, do manage to hit light speed. Congratulations, you're now bending the very fabric of space and time. Hope you brought a camera because things are about to get weird. Here's the deal: at speeds approaching light, everything you experience becomes, well, distorted. Einstein's theory of special relativity tells us that time slows down for you relative to the outside world. So while your friends back on Earth are aging normally, you're experiencing time in slow motion. You could travel for what feels like a few weeks, only to return and find that centuries have passed. Great for dodging responsibilities, not so great for keeping up with your favorite TV shows. Now, let's talk about that sneeze. Normally, a sneeze propels air and tiny droplets out of your nose at around 100 miles per hour. But if you're already moving at the speed of light, does that sneeze add to your speed? Does it move faster than light? The short answer? Nope, because once again, physics refuses to be fun. According to the laws of relativity, the speed of light is the ultimate speed limit. You can't go beyond it, no matter how forcefully you expel air from your nose. What actually happens is that, from your perspective inside the spaceship, your sneeze behaves exactly as it normally would. Your body doesn't feel any different just because you're traveling ridiculously fast. Inside your ship, physics remains familiar. Your sneeze still moves at its usual speed relative to you. But to an outside observer, say, someone watching you zoom by from Earth, things get weird. Because of time dilation, your sneeze would appear to be happening in extreme slow motion. If someone could somehow measure the movement of those sneeze particles from their stationary point, they'd see them creeping out at an agonizingly slow pace, frozen in time as if nature itself were buffering. To them, it would look like your sneeze is stretching across eternity. But wait, there's more. If your spaceship is traveling at light speed and you sneeze forward, what happens to those sneeze particles? Are they just stuck in place? Actually, yeah, kind of. If you sneeze directly in the direction of travel, relativity dictates that those particles still won't exceed the speed of light. Instead, their energy increases rather than their speed, making them behave more like high-energy radiation. In other words, congratulations, your sneeze just turned into a cosmic ray. But things get even crazier. If you sneezed backward, away from the direction of travel, those particles would still move away from you at their usual sneeze speed from your perspective, but to an outside observer, they'd appear to be nearly frozen in place. From their point of view, it would look like you sneezed and the droplets just hung there, barely moving at all. Imagine explaining that to NASA. So, let's recap. If you somehow manage to hit the speed of light, which, again, you can't because physics says no sneezing would still feel completely normal to you. Inside your spaceship, you wouldn't feel any different than if you sneezed on a lazy Sunday at home. But to the outside world, that sneeze would look like it was happening in extreme slow motion. The faster you go, the more time stretches, and the weirder things appear from an outside perspective. And if you sneezed in the direction of travel, your humble nasal explosion could theoretically turn into high-energy radiation. So in a way, you'd be weaponizing your allergies. But here's another fun thought experiment. What if you were traveling just under the speed of light? Would sneezing push you past the limit? Nope. Instead, the sneeze energy would simply make your already high-energy particles a little spicier. Kind of like adding a bit more heat to an already raging fire, but never quite getting past that ultimate boundary. At the end of the day, the real lesson here is that physics is weird, relativity is even weirder, and sneezing at light speed is just another reminder that the universe doesn't play by our rules. But hey, at least now you've got an absurdly fascinating topic to bring up at your next dinner party. If you enjoyed this little journey into the bizarre, make sure to hit that like button, subscribe for more mind-bending questions, and let me know in the comments what other absurd hypotheticals should we tackle next. Until next time, keep your feet on the ground, your spaceship hypothetical, and your sneezes firmly within the laws of physics.